The energy issue has been always an important subject in the development of human life. The energy has become a priority not only to meet the energy demands of industrial countries, but also to meet the demands of the increasing world population. Energy sources like fossil fuels are known to produce great contribution to the world's energy supply, but are expected to have limited reserves, and this threatens the future of the world's development at the present rate. Moreover, fossil fuels are also involved in atmospheric pollution and associated to global warming. To overcome these problems, man has focused on the development of new energy sources, and among them there is no doubt that the sun's energy, directly or indirectly, will play a vital role in the predicament. At the present time, photovoltaic systems directly collecting the sun's energy are increasingly used and represent a major trend in the solar industry and in the research sector of the science community. The development of a device which can improve the energy gain of the said system is a great challenge towards productivity. Our project, entitled Sun Tracker for Efficient Solar Power Collection, is an automated tracking system which will keep the solar panel aligned perpendicularly to the sun in order to yield an increase of solar energy compared to a static photovoltaic system. This study covers the construction of the device and how the different components involved will be used together to produce output. The scope of the project are the following. The system can only be used in powering devices which are 500 watts or below. It will have an LED that can indicate whether the output is ready for use or not. It will have a charging state indicator. It is self-powered. Charging will be cut automatically when the battery bank is full. On the other hand, limitations are set based on the specification and capabilities of the entire device. The following limitations are: the span of powering a device depends on the remaining battery stored. Since the system is single-axis, when the sun moves from north to south direction, the solar tracker will not be able to adjust accordingly. The device will not be able to withstand wind speeds greater than 150 km/h. Presented is the implementation of the actual device. It has two switches. The first switch is for the power of the main circuit located below the motor, and the other switch is for the output circuit at the inverter. It has four LED that serve as charging indicator, circuit on-off, fault indicator, and inverter on-off. The solar panel is inclined 15 degrees facing south direction, opposite to the hemisphere where the Philippines belongs to. It has three light-dependent resistors positioned at the left, right, and center of the panel, which serve as a sensor that sends signals to the microcontroller. These signals will be received and processed by the microcontroller that will control the movement of the motor, from rotating clockwise to counterclockwise or vice versa. Also, it is responsible for the charging of the battery and cutting it when the energy stored is full. The battery used is a 12 volts 12 ampere sealed lead acid battery that functions as the power source of the entire device together with the 500 watts inverter. Shown is how the device will be implemented in household setup. The solar panel with tracking system will be placed at the rooftop or at any open upper part of the house, and the case containing the inverter and battery bank will be placed inside the house. Presented is the blank diagram of the project Sun Tracker for Efficient Solar Power Collection. It consists of the input, process, and output block. The input block consists of the key factors that initialize the operation of the device. It is made up of sunlight, which is detected by the solar panel, and the luminance by the LDR sensors. The process block is composed of the Arduino Plus with 80 Mega164 that used to control the movement of the motor. It is also responsible for the disabling of charging when the battery is fully charged. Furthermore, the inverter is also part of the process block that converts 20 volts DC to 220 volts AC. The output block, on the other hand, is the process input. This contains the 220 volts AC supply that can be used to power devices which is not more than 500 watts and the actual position of the sun.